Welcome back, everyone. Today, we're tearing apart the future of personal tech. I'm David.
And I'm Sophia. It's great to be here.
We are going on a pretty ambitious journey today. We're looking at everything from the phone in your pocket right now.
All the way to the invisible infrastructure of tomorrow and how we'll interact with it all by, say, 2030.
Exactly. But before we get into all of that, just a quick message for you. Welcome, everyone, to techdaily.ai. You can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you're interested, just contact info@techdaily.ai to get started today. All right, so our mission today is to figure out what the next generation of personal tech actually looks like.
Right. The devices, the network, the interfaces.
We want to know why the smartphone, as we know it, is basically destined for replacement.
Yeah.
And what's going to make that replacement possible.
Mm-hmm.
Okay, let's unpack this. It feels a little like science fiction, talking about tech that can transfer our sense.
It does.
But we have to ground this conversation in an immediate reality, which is the environmental cost of the devices we already have.
Mm-hmm.
There's this constant pressure, right? Buy the new model every couple of years.
Mm-hmm.
And that creates this huge sustainability paradox.
That paradox is really the only place to start when you're talking about future hardware. It doesn't matter if you invent the most powerful chip in the world if it just adds to a mountain of e-waste.
Right.
The key thing, the insight that really needs to sink in for everyone is that the lion's share of a device's carbon footprint, it all happens during production.
So not while I'm scrolling or streaming video.
No, not at all. It's before you even take it out of the box.
So the most polluting moment in a phone's life is before it's even mine.
Precisely. And because of that, the impact of extending the device's life is, it's staggering. The data shows that if you keep a phone for 5 years instead of the usual 3.
It feels like forever these days.
It does, but if you do it, you cut that device's annual carbon footprint by about 31%.
31%.
And if you push it to 7 years, maybe with a couple of battery replacements, that number drops by 44%.
Wow, 44% just by not upgrading.
Yep.
That's a huge actionable thing for anyone listening.
It is.
But that really relies on manufacturers playing ball, doesn't it?
Oh.
They don't exactly make it easy to swap a battery.
And that's where you get this intersection of innovation and responsibility. It's called modular design.
Meaning you can replace parts yourself.
Yes. The battery, the camera module, the charging port, when those are user replaceable, it changes the entire calculation. The emissions from making and shipping those spare parts, that's paid off, environmentally speaking, after just a few extra weeks of using the device. Longevity becomes the smart choice.
That makes so much sense.
Yeah.
You've got to minimize the harm of production.
Yeah.
But here's the pivot. Devices are about to get so much more powerful, and they'll need a network that's, way beyond what 5G can do.
Right.
So even if we keep our phones for 7 years, what happens when the network itself can't handle what's coming next? Why is 5G already looking insufficient?
It's just a matter of scale, a matter of necessity. By 2030, the demand for connectivity will just completely overwhelm 5G's capabilities. We're moving into an era of massive extended reality, or XR, complex digital twins for industry, things that need zero latency.
And 5G wasn't built for that.
It was never designed for that density or that kind of real-time global interactivity, and that's why 6G becomes necessary.
So we're talking about completely redefining wireless communication.
Yeah.
If 5G drove the Internet of Things.
6G drives the Internet of everything.
Here's where it gets really interesting. What are we actually looking at? What are the performance targets for 6G compared to what we have now?
The goals are, they're exponential. They're designed for truly instantaneous connection. So let's look at the data rate. 6G is aiming for 1 terabit per second, TBPS.
1 terabit. And 5G's peak is?
10 gigabits per second.
100 times faster.
100 times faster, yes. And speed is only half of it. Latency is targeted at an incredible 0.1 milliseconds.
Which is 10 times better than 5G's 1 millisecond.
10 times better. Then you have density. It has to handle over 10 million devices per square kilometer. And linking back to our sustainability point, it's expected to be 10 times more energy efficient than 5G.
100 times faster, 10 times more efficient. That 0.1 millisecond number is what really gets me. What kind of application needs that? I mean, what difference does that tiny fraction of a second make?
It enables things where the feedback has to feel real, truly real.
Like remote surgery.
Exactly. A millisecond of lag there could be catastrophic. Or, hyper-realistic, holographic calls where any delay just shatters the illusion of presence. That's the foundation for transferring sensory data, touch, smell. The system has to react in real time.
Okay, but those numbers,
Yeah.
they sound impossible with the radio waves we use today. What kind of engineering magic makes a terabit per second happen?
It's a fundamental break. We have to move up the spectrum into the terahertz frequency band. We're talking up to a 10 terahertz maximum.
Wait, terahertz signals are great for data, but they're terrible going through walls or even rain. How do you get global coverage with that?
You can't with just one layer. That's why 6G is a total architectural overhaul. It's a 4-tiered network. You have space with satellites, air with drones, terrestrial, which is our current base stations, and even sea networks for underwater comms.
If one later fails, another one just picks it up.
It has to. And for dense indoor areas where terahertz really struggles, you need something new. That's where visible light communication comes in, VLC.
So using the lights in this room, my office lights,
Yeah.
how does a light bulb transmit data?
Exactly. VLC uses the visible light spectrum, an incredibly high frequency range from 400 to 800 kilohertz. It's simple, really. The LEDs flicker on and off, creating binary code, but they do it far faster than the human eye can see.
That's amazing. So a bank of overhead lights becomes like a fiber optic cable beaming down to every device in the room.
In essence, yes. And that combination is what allows the jump from the Internet of Things
Connecting thermostats and sensors.
to the Internet of Everything, the IoE. It's about integrating data, things, people, and processes into one seamless system. We call it 3CLS co-design. Connectivity, computing, control, localization, and sensing.
Which immediately raises the question, what devices are we using to interface with this world? The consensus seems to be that the smartphone's days are numbered.
The consensus is very strong. The post-smartphone era is all about form factors that are either invisible or worn on the body. It's about less screen time. The main focus right now is on AI-powered smart glasses. You see Meta with its Ray-Ban display. Apple is working on something. They are all betting that glasses become the new central computing platform.
The cockpit for your digital life.
That's a good way to put it.
But if the computer's on my face, how do I control it without, waving my hands around in public or talking to myself all the time?
That's the next big challenge, and it's why we're moving from physical controls to neural controls. Meta is working on a neural band. It's an EMG wristband that reads the tiny electrical signals from your forearm muscles.
The signals that happen before I even fully move my finger.
Exactly. It reads your intention to move. It translates those tiny muscle twitches into commands for the glasses. It's intuitive. It's hands-free.
It's already mind-bending, but the concepts go even further, don't they? The ultimate interface is much more direct.
It is. The ultimate connection is the brain-machine interface, or BMI. That's about analyzing brain signals directly. And to transfer that incredibly rich data stream from the brain, you need constant data rates of at least 100 gigabits per second, probably higher.
Which is already 10 times faster than 5G's peak speed.
It is. This absolutely requires 6G. And it's not just about moving a cursor with your mind. The long-term goal is to transfer the 5 senses.
Touch, taste, smell.
All of it. Through what's called the tactile internet. Controlling virtual objects and actually feeling them.
It's an incredible progression. I mean, think about the first camera phone, the Sharp JSH-04 back in 2000. It had a 0.11 megapixel camera.
And a processor that could barely handle it.
Right. And now we have computational photography with dedicated AI chips doing super resolution zoom and 3D sensing. That whole evolution relies on more data, more processing.
And the next step, these new interfaces, they demand the new network. The two have to be co-designed.
Which brings us to maybe the biggest challenge of all, usability and trust. If these systems are so smart they adapt to us automatically, are they actually better? This raises an important question.
It does. We're talking about a shift to what are called adaptive user interfaces, or AUIs. They adjust based on your context, location, task, even emotion.
So the system is guessing what I need without me telling it.
Yes, and this is where efficiency doesn't always equal effectiveness. Some usability research on this found a really fascinating tension. For example, voice command adaptivity. It was 6% more efficient.
So faster.
Faster, yes, but it was 19% less effective.
Wait, less effective. How is something faster but fails more often?
Because the accuracy wasn't there. It failed to recognize an accent, or it misunderstood the context. It tried to be smart, but it ended up being unreliable.
So the adaptation has to be in the appropriate context.
Precisely. On the other hand, simple things like an adaptive LED notification were incredibly efficient and effective. The lesson is that AI has to be paired with total reliability.
And beyond just usability, there's security. If 6G is the Internet of Everything, the attack surface must be immense.
It is terrifyingly large. The scale, plus new things like multi-access edge computing or MEC, it just widens the security gaps. You're creating billions of new potential points of failure.
But the biggest barrier might not even be technical.
I agree. It's likely social and psychological, especially with smart glasses. A smartphone tracks us, sure, but we can put it in a pocket. The feeling of having cameras and sensors always on your face, it generates this visceral sense of intrusion that a phone doesn't.
It's the difference between a device that could be watching you and one that feels like it's always watching you.
And watching everyone you look at. That psychological hurdle, that feeling of constant exposure is a major, major barrier to adoption.
And on top of all that, there's the economic challenge. These AI glasses, the 6G services, they're going to launch at premium prices.
They always do.
And that risks creating this world where only some people get the benefits. True ubiquity needs access for everyone, not exclusion. So we've really come full circle here. We started with making our current tech less harmful.
With repairable phones.
And we've ended up in a future where 6G enables these entirely new human-machine relationships.
The key takeaway for you listening to this is that 6G is about integration. It's not just about speed. It's the co-design of those 5 things we mentioned: connectivity, computing, control, localization, and sensing. That's the 3CLS paradigm. And all of it is orchestrated by AI.
So what does this all mean? We've talked about a future where devices are on our faces, maybe even reading our thoughts. Given that constant presence, that power, will the ultimate luxury in this new world not be having the fastest connection, but having the ability to choose and enforce a period of total digital respite? Something to think about as you navigate the smarter world ahead.
Indeed. Thanks for joining us for this discussion.
We'll see you next time.